So what do we mean by seismology? Seismology is the study of earthquakes, and the way these earthquakes are typically studied is by seismic waves that move through the earth. So this is an early seismograph here, and this is an ancient Chinese seismograph. So this is a seismograph that was used to try to indicate which way an earthquake might be coming from. So as you can see here, there's kind of like this heavy kind of bell-shaped thing in the middle, and on 8 different sides of it, north, south, east, west, and the directions in between, there were these dragons, and that each of the dragons held a marble in its mouth. And depending, when an earthquake occurred, it would kind of push the seismograph in one direction or another. And depending on which way it was pushed, the marble was a little heavier than the friction of the mouth holding it, the dragon's mouth. It would get pushed in that direction. The marble would be left in the air and potentially fall into the mouth of these frogs that were around it. So this was only meant to indicate which direction an earthquake was coming from, but of course we've made great advances with seismographs since then. This is what a current seismograph looks like. And first of all, the seismograph is buried underneath the ground so that no one's kicking it at the surface or other things, or animals are bumping into it or anything like that. They're buried in the ground. And it's the same sort of idea. They have a heavy weight that's attached to the structure, to the seismograph. And original ones, of course, this is all electronic now, but it used to just be a pen that would sit on the bottom of this heavy weight. And because the pen and the heavy weight have inertia, they're not going to move back and forth, and they're only attached by a wire. They're not going to move back and forth very much when an earthquake occurs, but the entire earth is going to shift back and forth. And that's going to leave a trace on this piece of paper, which we call a seismogram. And the seismogram would then record the earthquake, and we would be able to tell things about how the earth was moving by looking at this seismogram. Here's what a typical seismogram would look like when an earthquake occurs. It's marked in minutes, so each one of these yellow and red lines is 1 minute of time because it's turning around that drum over time. And so when an earthquake first starts to be recorded, we get squiggles of movement associated with the movement of the earth. And as we'll see, this first one is called a P wave. Then after some time that might die out a bit, but then more stronger waves associated with the same earthquake would come later as S waves. And then finally, movement on the surface, kind of almost like waves on the ocean, but instead on the physical surface of the earth would cause these surface waves to occur. This is a seismogram once again, and we're going to talk about what those particular waves, how they propagate through the earth.